Welcome you guys. So today we're going to discuss about the kinematics of machines in this video. So mainly we're going to study the kinematics of machines in the fourth semester of mechanical engineering, and the subject code is 18ME44. So why we need to study the kinematics of machines? See, mainly the kinematics of machines is nothing but a study of motions and mechanisms. See, why if to do any work in the machine we require some mechanisms. To generate some mechanisms we require some motions. So without the motions, the mechanism cannot able to be generated, or without the mechanisms, the machine cannot able to work by its own. This is what we're going to in depth. We're going to study about the motions and mechanisms in this kinematics of machines. So in this video, mainly we're going to study about the introduction of the kinematics of machines. What is the introduction? What we're going to learn about this kinematics in this particular model, and the various definitions related to the kinematics of machines that we're going to be completely studying this kinematics of machines. So the major intention of studying the machines is kinematics of machines is in the mechanical engineering is to because of to learn the motions and mechanism, how the motions can able to convert to the mechanisms, and how the mechanisms can able to convert to the one to the other type of useful work. For example, if we take any machines, all in inside the machine, all the mechanical parts are interlinked to each other. So what happens once the if we interlink to the each other, so all the parts will be interlinked each other. Whenever we required a different types of motion or mechanism, it can able to convert from one form to the other form. For example, we required a reciprocating motion. So inside that mechanism, it can able to convert from rotary to the reciprocating, or from reciprocating to the rotary. So like this, different mechanisms can able to be converted by using the different types of motions, right? So each mechanisms or each motion we cannot able to individually make a setup or a machine for each mechanism. So that is the reason why the machine size has been reduced, because of the all the motions are motions which will be related to one to another inside the mechanism. So all the mechanisms are interrelated to one another to form a one complete machine. See, to form any useful work on the machines, so the motions will be converted to the mechanisms, and that particular mechanisms will be interlinked or connected to the machine to do some useful work. So now we're going to see about the introduction of the kinematics. Yes, sir. First we're going to say about the introduction. See, the study of mechanisms involves its analysis as well as synthesis. Whenever we're going to study the mechanism, so the mainly the studying of the mechanism is it involves the analysis as well as synthesis. So then now we'll get a question, that is what is analysis and what do you mean by a synthesis. So analysis is nothing but studying the study of motions and forces concerning with different parts of a mechanism, where synthesis is nothing but only it involves the design of that particular parts. So when we go differentiate between the analysis and synthesis, means analysis is nothing but study of motions and forces which is acting on that particular parts of a mechanism, whereas the synthesis is nothing but only it involves the design of that particular parts. See, when we want to analyze the motions or forces, first we require a parts. How we going to make that parts? The parts is nothing but first we need to design that parts, then only we're going to manufacture that parts, then we're going to assemble that parts, then we're going to make one complete machine. So this is what the analysis and synthesis. Now coming to the mechanics. What is the mechanics? Mechanics is nothing but a branch of scientific analysis which deals with the motion with respect to time and force. So mechanics is nothing but a scientific analysis which deals with the motion with respect to time and force. Now we'll come to the kinematics. What do you mean by kinematics? Kinematics is a study of a motion without considering the forces which produce that motion. See, whenever we are producing or we are generating any type of motion, there will be some forces which is acting on that motion. Right? If we convert from any form to the motion, from one form to the other, or we are generating the any motion, reciprocating motion, linear motion, oscillating. Like if you take any example, if you're generating any type of motion, normally some forces will be there. Even if you take in any machining process also, there will be some cutting forces which is acting on that particular tool and the workpiece. So similarly here also, whenever you are producing any type of motion, we will be having some uh, forces. So the kinematics is nothing but only the study of motion without considering the forces, with the forces which is caused to produce that motion. So we're not going to consider, we're going to neglect that forces, only we're going to consider the study of motion. So Kinematics of a machine deals with the study of the relative motion of all the machine parts. So we're going to study the relative motion between the machine parts. So it involves the study of position, displacement, velocity, acceleration of all the machine parts. So the main thing is kinematics of machines is nothing but a study of motion without considering the forces, and we're going to study the relative motion between each parts. See, all the machine parts has been interlinked inside the machine, so there will be relative motion between each and other, all the different parts will be having a relative motion among themselves. So this is what the kinematics, what we're going to study about the kinematics as well as in mechanics. We have discussed about the analysis, mechanics and kinematics. So next we're going to study about the dynamics. So what do you mean by in a dynamics? What do you mean by in a kinematics? We have been discussed. So in the kinematics, we are going to study only the motions without considering the forces. So similarly, what we're going to study in the further in the dynamics is the dynamics of a machines involves the study of forces acting on the machine parts and the motions resulting these forces. So in the kinematics means we are going to study only about the force motions. So in the dynamics, we are going to study about the forces which is acting on that particular motions, which is causing that, which is generating the forces to cause that motions. We're going to study about the dynamics. So next, what we're going to say about the motion. Motion is nothing but an, generally if we call it a motion means change of position with respect to time or a displacement. So plane motion means a body as in a plane motion if all the points move in a plane which is parallel to some of the reference planes. See, for any motion there will be any part, there will be some reference. So in order the plane motion means it moves the, all the points will move in the parallel to some of the reference points. A body with a plane motion will have only the 3 degrees of freedom, and a linear along with the two axes, that reference plane will move in a either rotational, angular or a translation. See, for example, if we take any type of body which is moving, which is having a body which is enabled to move only in the 6 degrees of freedom, right? See, if we consider any type of body in a space, normally it will be having a 6 degrees. Either it can able to have a translation motion, a rotational motion, and either a combination of these two motions. If you take xyz means it will be having a 3 degrees at a time. All these motions cannot able to move in at a time, but based on the restricted motions we can able to consider all the 6 degrees of the freedom will be there along with the x, y and z axis. That is what we called as a plane motion. First we will see about a translation motion. You can see the diagram along with a body as a translation. If it moves so that all the straight lines in the body will move to the parallel positions. See, if we can consider this as an example, a body which is having a translation motion so that all the straight lines in the body will move to the parallel positions. So in this again, the translation motion has been classified into different categories. We can able to see the rectilinear translation and we can able to see the curvilinear translations. So generally, a translation means a body will be moving so that all the straight lines in the body will move to the parallel positions. So if we want to same translation, I need to convert to the rectilinear translation means. So rectilinear translation is the motion where all the points of the body move in a straight line paths. See, the difference between the translation, general translation and rectilinear translation means in the general translation, all the bodies will move in the straight lines in the body to the parallel positions. So in the rectilinear translation means is a motion where all the points of the body move in a straight line paths. So that is what we call it as a rectilinear translations. So next, in a translation in which the body moves along with the curved paths. If the body is moving along with the curved paths, that is what we call it as a curvilinear translation. So this is what the difference between the translation, rectilinear translation, curvilinear translation. If the body moves in the curved path, so what we call it as a curvilinear translations. So this is what the difference between or the different types of translations what we can able to see or identify in the motions. So these are the some of the basic definitions that what we have been discussed in the in this video regarding the kinematics of machines. So mechanics, analysis, synthesis, dynamics, and the different types of motions, and we have been discussed that is in this video. Thank you.